So a hypothesis test is a process, just like in science, that you use sample statistics to test a claim about the value of a population parameter. This population parameter can be a mean, can be a proportion, can be a variance, or a standard deviation. This whole unit is separated into those things as well. Mean, proportion, variance, standard deviation. The same things we did for your confidence intervals. And we'll go through one at a time. We start with the mean, that's always the easiest. So for instance, consider a manufacturer that advertises his new hybrid car has a mean gas mileage of 50 miles. He's giving this from his population of all his hybrid cars. If you suspect that this is not 50 miles per gallon, how could you show that his advertisement is false? You cannot test all the hybrid cars, so therefore you get a random sample using all your random sample means that you knew from the population, and you measure the mile of each to make sure that you make a reasonable decision about the population. If the sample mean differs enough from its advertisement's mean, you can decide that the advertisement is not really wrong, but false. To test the population that it's 50, you're going to take random samples of 30, and you're going to find your sample mean was 47 miles per gallon with a standard deviation of 5.5. It's usually the standard deviation that gives us that extra, am I close, am I not close? Does this mean that it's false? To decide this, we do the unusual. We always assume that the advertisement is correct. We're always assuming that they're correct first. So you set your population mean to 50, you test the sample, there's great calculator steps for this as well, and you make a conclusion. You can conclude that the advertisement is probably false, or on the flip side of this, you only sampled 30 people. Maybe your sample wasn't a very good representative of your population. We're talking about a whole population of hybrid car users, and you only got 30. So that's something you have to retest and retest and retest before you actually prove them wrong. Advertising is really big on, you see commercials where they advertise, like you probably don't remember, the most famous one was the doctors that prefer Crest, was 3 out of 5 doctors prefer Crest. Someone who makes that statement has to back that up. They have to show where their results came from. If you watch this, like I'm advertising my Shark vacuum, they say Shark vacuums have more power than your leading brands. Do they tell you what your leading brands are? No, because if they did, they have to back that up. They have to test each one of those leading brands, and they have to statistically prove that their vacuum is better than theirs. So you always have to be careful the statements you make when you're giving out statistics. It has to be based on something true. And again, we don't say that they're crazy. We don't say it's wrong. We say it's false. We disagree. Again, because we're working with a sample, you're taking your standard deviation over your sample size. You're doing this part because we're dealing with samples, which shrinks this in a little bit. Okay. Again, I'm just kind of pointing out what we're going to be going through so that you know where it is. This is probably the most important part right now. Stating a hypothesis. So if Olivia, could put your phone away right now and concentrate on this, I would be very happy. A statistical hypothesis is a verbal statement or claim about a population parameter, mean, a proportion, a variance, a standard deviation. Those are parameters. To test your population parameter, you're going to make a pair of these hypotheses. One that represents the claim, one that is the complement, the opposite of that claim. If one of these hypotheses is true, then the other one has to be false. The null hypothesis or the alternative hypothesis may represent the claim. Now, here's the key factor. We're making an HO and an HA. The HO is considered our null statement, the H sub O. This is our null. The HA is our alternative. There's H sub A. They're just subscripts, like X sub 1, X sub 2, X sub 3. They're just subscripts. But the key to this is the null hypothesis contains any equal signs. The alternate hypothesis is the opposite and does not contain an equal sign. So if I say this, the mean average in this class is greater or equal to 86. Because this has an equal sign, this will be my HO. This also happens to be my claim. My claim is the mean is greater than or equal to 86 on the test averages. Because it has an equal sign, that's my HO. I have to make a pair of these. My HA says it's the opposite of this. So if it's not greater than or equal to, what else could it be? Less than 86. So I have a pair. Only one contains an equal sign, one doesn't. Because if you think about it, if I said that the test average is greater than or equal to 86, and the opposite said it's less than or equal to 86, the equal was used both times. It can't be used both times because one is the hypothesis that we can prove true or false. If one is true, the other is false. So this is key right now, that you're going to be finding two hypotheses. The plural of a hypothesis is hypotheses. Do you ever work with hypothesis statements in science? Right? Do you ever make two, or you just make one? Make one. And we prove it true or false, right? So we need something to take the buffer when it's false. We need another statement in there. So we're going to translate these claims just so that you can see what we're looking at. These are what your claims are going to look like, guys. And I know it's hard to visualize yet because we don't really have anything just yet. So if my statement says less than or equal to, then my opposite says greater than. And here it is in words. If my HO is less than or equal to, then my opposite, my alternate one, is greater than. It's just a chart in words. And it's different words that you'll hear. Remember, everybody doesn't always say greater than. Sometimes we say not less than. Sometimes we say fewer than. Sometimes we say, I never really hear below or above. But sometimes it comes out like that in a statement, like in terms of temperature. It could be below 56 degrees. It could be above 25 degrees. So these are things you're going to look for. Okay? Just complements of each other. So let's try one. Let's try a couple. A school publicizes that the proportion of students who are involved in at least one extracurricular activity is 61%. The first thing we need to do is write this down, the population parameter. What are they talking about? Are they talking about a mean, a proportion, a variance, a standard deviation? What are they talking about there? Proportion. So remember, this is the population. So we represent this with the P. When I say at least in one extracurricular activity, the at least in this one doesn't affect our outcome of this. Sometimes it does when we get down here, but this just is a qualifier for this. So be careful of the way you see the words. What I'm looking for is after the is statement. This is what I'm looking for. That's when it's going to say is at least or at most. This one is just part of the statement. A bad way to phrase this. A school publicizes that the proportion of students who are taking one extracurricular activity or more, or at least one, is 61%. That's my statement, that is. So I write this is my claim. start like this. This is what they're claiming, right? That to be in at least one activity or more is 61. I have 61% of my students taking one or more extracurricular activities. That's my statement as a principal. I look to see. It has an equal sign. Which one keeps the equal sign, the HO or the HA? HO. This becomes this one. The HA is my complement. What is the opposite of is? Or equal to? What's the opposite of equal to? Not equal to. This is my opposite. So I get a claim, I get an HO, and I get an HA. In case you're confused, I'm on page 350. This is what I'm looking for. Find first, make a math statement, find your claim. This is your math statement. The next thing I do is separate my HO and HA. Okay. A car dealership announces that the mean time for an oil change is less than 15 minutes. I look to see first, what are they talking about? What's my population parameter? Mean. Mean time. And nobody usually says mean time, they say average time. So if it says average time, we still know that it's the mean. This is my parameter. This is important because there's not x equals anymore. Okay, now for an oil, here's my is statement. This is what I care about, is less than. See where this less than is a little different than up there where they qualified that one? You got to watch for this. So I start like this. I write my claim. What's my claim?
The mean is less than 15.
Good. This is my claim. I own this car dealership. Would I claim that it's greater than? Would I be foolish to claim that? Would I tell you, oh, the mean average time is greater than 15 minutes. Would you stay? No. So it depends who's saying this. As the car dealership, I want to make this sound as good as possible. As maybe someone visiting there, I said, oh my gosh, the average wait time is at least 15 minutes, 15 or more. But my car dealership guy is saying less than 15 minutes. So is this my HO or my HA? HO? Why? HA? Why? No equal sign. The HO contains the equal sign. So what is the complement, the opposite of being less than? More than. More than. So if I just did this, what happens? Who gets when it's equal to 15? Or equal to. And the HO has to contain the equal sign.
Why does that have equal sign again?
Because the rule, that just by rule, the HO contains the equal sign. When we actually get to do this, we actually graph the tail of the HA, but the HO gets the equal sign. Yeah, that's just a rule. A company advertises that the mean life of its furnace is more than 18 years. First, find your parameter. What parameter do we need? Mean. Mean I represent by what variable? Which one of those population parameters should I use? Mu. Good. Here's my claim. This is my claim. This is what is being said. I look for the is. And I have is more than. What is more than? What math statement does that make me? Less than or equal to or greater than? Greater than is more than 18. Is that going to be my HO or my HA? HA, why? Good. There's no equal sign. And the complement of this guy is what? Less than or equal to. Do I cover everybody? I should be able to make a number line with those two statements and cover every number on it. So my first one says, at 18, I am open, but more than. I can't include 18, right? My second one says, include it and less than. I cover all possible things. So when I go to test this, one can be true, but they can't be true at the same time, right? So if one is true, the other is false. And that's where my testing comes in. Okay? So let's have you guys set up these three. I want to see everybody. Alright, so a consumer reports that the mean life of a certain type of automobile is not 74 months. I want the claim. Devin, what'd you get for the claim? You?
No,
I did the HO for like the plane part.
So what's the claim now? All right, what's your HO?
I did
Okay, U, use some U, equals 74. That's the HO, because it has an equal sign. So what's its complement? Does not equal 74, okay, because this has no equal sign. So his claim is which one of these? So how do we say this? Not equal. So which one is saying not equal? HA. Not 74 months. It could be anything but 74 months, right? So not, remember they play with the words a little bit. So this is not equal to 74. That's your claim. Start with that. Because the claim, you know the box that I handed you guys out? I handed you out a little sheet about there was a box of information on here. See this box that I gave you? This is where it's going to come in important. Where it says your claim is your HO, your claim is your HA. These are the words we're going to use to disprove those claims. So first I have to know what is my claim. I have to know what is my HO, my HA. I have to know what it is I'm testing. Okay? Good. An electronics manufacturer publicizes that the variance of the light of its home theater system is less than or equal to 2.7. Because that's probably years, right? 0.7 years. So, claim. Chris, what's my claim?
Variance is less than or equal to 2.7.
Okay, it's less than or equal to 2.7. I write my population parameter. It's got to be the sigma squared. And is this going to be my HO or my HA? HO, because why? It's got an equal sign. What's my HA? Greater than 2.7. Good. Okay, good so far? Doesn't matter who gets the greater, who gets the less than. What we care about is the equal sign. Okay, a realtor publicizes that the proportion of its homeowners who feel their house is too small for their family is more than 24%. So Michael, what's my claim?
probability is greater than 0.24.
So probability proportion is greater than 0.24. Good. I like that you flipped it to a decimal. Good. Okay. Is this my HO or my HA? HA. And what's my HO? Less than or equal to. So, we see a lot going on here. Does it matter what my claim has an equal sign or not? No. Whatever they state is what my claim is. We also use 3 different parameters. We use the population mean, we use the population variance, We used the population proportion. We did at no point put an x equal in here, right? So these are important. The next step is all my HOs have to contain my equal sign. Do they all contain my equal sign? Then we're good to go. Questions? Okay. I'm going to have you guys try some. Oh, you're so much in luck. Yeah, well, you're going to try more. Because I just love to have you try these. Okay. I want you to do these problems up here. Hang on. I'll make sure it's right. I don't want you to do 31 through 36. I just want you to do page 359 to 360, 11 through 20, and 25 through 30. 11 through 20, 25 through 30. Don't write down the answers. Don't write down the answers. You have to do those. 11 through 20, 25 to 30. Write down the page number. Did anybody get that page number? 358. Thank you.